Alright, let's see how we can add and subtract sets. Okay, how do we add and subtract sets? So let's see this example. The first one, if you have n square root of k plus n, let's see, n square root of k. Now, square root of k and this square root of k, they are the same. So you have k here, then the square root, they are the same. So which means that it permits us to what? To add their coefficients. So if you see something like this, whereby the radical, or let's say the radicand are the same, then it permits us to add their coefficients. So you have m plus n, and take one of the square roots, so square root of k. The second one, you have, let's see, the same thing, m square root of a minus n square root of a. Now this time around, the same square root, we have a here, and the same root signs, so we can subtract their coefficient. So subtracting their coefficient, you get m minus n, then square root of what? A. You just take one. So if they have the same root signs, then you can add or subtract their coefficients. Take note of this because that's what we'll be using to solve more examples. Let's see illustrative examples. Alright, let's see this. Evaluate, which means you should get the value of this expression here. There is no equal to, so it's an expression instead. Now, square root of 147 minus square root of 75 plus square root of 27. Now, you can see that for now, the values or the numbers inside the root signs are not the same. So when it happens like this, you need to simplify. You have to simplify or reduce the sets to check whether you can either subtract or what? Add. So let's simplify the expression or the sets here. So when it happens like this, and you check that, then values inside are not the same. Then you don't know whether you subtract or add. So you need to reduce the set to its simplest form. So let's reduce square root of 147. And square root of 147, we need, that's 49 times 3. We need 49 times 3. Minus square root of 75, we need, that is 25 times 3. Two numbers, when we multiply, you get 75, but one of the numbers should be a perfect square. So 25 is a perfect square, 49 too is a perfect square. Now let's see 27. That's square root of 9 times 3. Now 49, we can split this one so that we have square root of 49 times square root of 3 minus square root of 25 times square root of 3 plus square root of 9 times square root of 3. Let's place that in brackets so that we have this. Now square root of 49, we have 7. Then we attach the square root of 3 minus here we have 5. We attach square root of 3 plus 9. You get 3 square root of what? 3 here. Now, you can see that they have the same root signs. So that's square root of 3, square root of 3, square root of 3. So we can subtract, then add their coefficient. So we get 7 minus 5 plus 3. Then we take one of the root signs. Now, 7 minus 5 plus 3, let's see, 7 plus 3 will give us 10. Then we deduct 5 from that, we get 5. So 5 square root of 3. So this is the value of the whole of this expression. Let's move to our second example. Now, this is a BC question, that's BC 2024, and they are telling us to simplify 3 square root of 50 plus 2 square root of 45 minus square root of 2 plus square root of 5. So let's see our solution. Now, 3 square root of 50. Don't forget, we need to simplify. We need to simplify the sets because we do not know whether they are what? They are like terms or they are not what? Like terms. Okay? When they are like terms, you can what? You can add their coefficients. When they are unlike terms, you can't add their coefficient or you can subtract their coefficients. So now let's see. Now we have 3 square root of 50 plus 2 square root of 45, then minus square root of 2 plus square root of 5. Now let's see. 3 square root of 50, which is 25 times 2. 25 is a perfect square. And plus here 2 times square root of 45. We get 9 times 5. 9, 5, 45. 9 is a perfect square. Minus square root of 2 is already in its simplest form. So we still have square root of 2. Plus the same thing applies to square root of what? 5. Now let's split this one. 3 times square root of 25 times square root of 2 plus 2 times square root of 9 times square root of 5 minus square root of 2 plus square root of 5 here. Now 3 times square root of 25 we have 5 times square root of 2 plus 2 times square root of 9 we have 3 times square root of 5 minus square root of 2 plus square root of 5. 3, 5 we have 15. Then times square root of 2 is still square root of 2. Don't forget 15, we'll just multiply the invisible number here 1. So you still get 15. 15 cannot multiply 2 because it's not inside the root sign. If you don't understand, go to my second video on the properties of sets and you know how we had that. Then plus 2 times 3 we have 6. Then we drop our square root of 5. Then minus 2, that's minus square root of 2, then plus square root of 5. Now let's see the like terms. Square root of 2, square root of 2. They are like terms, so we group. We have 15 square root of 2. Then we take the whole of that, the sign in front, minus square root of 2. Then here plus 6 square root of 5. Then here plus square root of what? 5. Now, they are like 10. Square root of 2, square root of 2. So we subtract their coefficients here. 15 minus 1. So we get 15 minus 1. We take one of the square roots. Then plus here 6 plus what? 1. 6 plus 1. Then we take one of the square roots. 15 minus 1, we have 14 square root of 2. Then plus 6 plus 1 is 7 square root of what? 5. So with this, square root of 2 and square root of 5, they are not the same. The radicand are different. So which means that we cannot add their coefficients. So it becomes like 10. If you don't understand, please play back the video for better understanding. So to simplify this expression, that's the answer. 14 square root of 2 plus 7 square root of 5. See you in our next example. Alright, still on the BC 2024, we have another question which is inside the BC 2024. That's evaluate. Still, they are telling us to find the value of this expression. Square root of 75 plus square root of 18 minus square root of 27. So we need to first simplify.